This presentation is a little chat about experiments in the UAS. We do all sorts of experiments and we organize surveys by the experiments they contain. I mentioned this briefly this morning. If you go to the survey page and then you click on survey by experiment, you get a list of type of experiments. These are the broad categories that we use to put surveys together according to the experiment that they have. This list, as you can see, is relatively short. This is on purpose. Because of that is somewhat arbitrary, and probably some of these categories are a bit too broad, but let me guide you through this list and tell you what these things are. So the first item is auxiliary randomization. This is not really a true experiment. This is just a set of randomization that we routinely do in every survey. Every time there is a list of answer options, we randomize the order of the list to avoid ordering effects. Sometimes we randomize the order of a specific section within a questionnaire, because we may worry that if we ask about a certain topic, then the answers to the following topic are going to be affected. So pretty much all surveys in the UAS contain some sort of randomization of this kind. We put them there. Keep in mind, these are not true experiments. Then question wording experiments. These is very interesting for survey methodologists. Sometimes we ask a question and we wonder whether if we rephrase the question may work better or worse. So the way to assess this is to run an experiment. And I'm going to give you a very specific example of some work we have done in this dimension. Then we have information experiments. This is probably the closer we get to field experiments. We are online, so the only way to intervene is to provide information. So what we do, we randomize the sample. Some people get some sort of information, some others don't. And then we try to assess the effect of the information we provide on decision-making or on knowledge of specific topics. There are several experiments of this type about social security rules. You give information to a subset of the sample, not to another, and then you compare their knowledge or their answers in terms of claiming benefits and things like that. Another example, we provide, for instance, historical stock market returns to half of the sample, and we don't provide this information to the other half, and then we ask about stock market expectations in the future, and we see big differences between the two groups. Hypothetical scenario experiments. This is another kind of category that's pretty common. One example could be you receive 2 job offers. They are exactly the same in all dimensions except 2. They have a different level of flexibility of work schedule, and they are paid different amounts. So let's say the job that has a more flexible schedule pays you less, and the job that is a more rigid schedule pays you more. Which one do you prefer? So from these kind of experiments, we can infer, for instance, how much people value flexibility in the job. Product choice experiments. In this case, people are given a list of products that could be, for instance, insurance policies, and then they have to choose which one they prefer. Again, we randomize some aspects of these policies to infer what kind of elements of these policies are valued the most. Then we have vignettes. That's another very common tool that we use. An example is the poverty vignette that we have been using throughout these years. You have some characters. The characteristics of these people are randomly assigned. And you may read something like, John is a single man. He lives with another household member. He makes $100,000 a year. He pays $200,000 to $2,000 a month in rent. How difficult do you think it is for John and his household to make ends meet? That's one type of vignette that we use, and we have tons of examples of this type. Then we have monetary incentives experiments. These are implemented very often when we ask our respondents to undertake tasks or surveys that require a little bit more of an involvement. For instance, we give them Fitbit and so that we can track their physical activity, or we ask them to link their financial accounts so we can see their transactions. Well, these kind of tasks, as you can imagine, are a little bit more demanding and involving. And we wonder before we launch the main study whether people need different kind of incentives to participate. Most of the time we run a pilot where we experiment with different monetary incentives, and depending on the lesson we learn, then we adopt one type of incentive in the main study. And then we have tasks. Tasks here can be with or without affecting payments. Think of tasks as really laboratory experiments. So tasks that typically people give to respondents or subjects into a lab environment are implemented or can be implemented within the UAS. Researchers that administer this kind of experiments are worried about how seriously people take these tasks. So most of the time, these tasks are incentivized. So let's say the task is choosing between two different lotteries. Well, the outcome of your choice is going to determine part of your final payment. By making these tasks incentivized, you also increase the focus that people use when participating. So as I said, if you want to you look at the surveys by experiment, go to the website, and there is the subsection, and you will see the list that I just showed you. If you click on each one of the items, let's say in this case, I'm clicking on information experiments, you see the list of all the surveys that contain that type of experiment. And of course, a brief description of what that category is about. Now, let me briefly give you two examples. This is work that I've been involved in, and I would like to share some of these results with you. And the purpose of this is to not only showing you what we have done and we are currently doing, but hopefully to provide some inspiration if you are thinking of a study that involves an experiment and you wonder whether this can be implemented in the UAS. I hope that this kind of illustrations can give you an idea if you want to run the study with us. So the first one is a question wording experiment, and you find it in the survey number 117. The goal of this was to find the best way to elicit bank account ownership in an online survey. And eventually this led to a paper with Mick Cooper in the Journal of Survey Statistics and Methodology. So you may think asking people whether they have a checking account is a pretty easy question to ask, and the answer should be easy to provide. Well, probably you have to think about it twice, especially because that depends a lot on where the question is in the questionnaire and about the survey mode, whether you are talking about a survey that is administered through an interviewer or is self-administered online. You know that we use the HRS questionnaire. In the first wave, we observed that the bank account ownership, so ownership of a checking or a saving account, was incredibly low, 55%. We were kind of surprised by these results, so we went back and tried to understand why. Well, in the HRS questionnaire, the question about ownership of a checking or a saving account comes after a long series of questions that takes probably 15 minutes about other financial assets. By the time you get to the question about checking accounts, the question says, aside from anything you have already mentioned, do you or your partner have a checking or a saving account? Now, in the absence of an interviewer that may say or remind you that you have not been asked about checking account, you may think, wait a second, probably this question has been asked already, is telling me aside from anything else, so I'm going to say, no, I don't have it. We were curious about whether this was a plausible explanation. So in the second wave, we simply removed the first part of the sentence. So instead of saying aside from anything, blah, 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 we just say, do you have a checking account? And bank account ownership climbed to 80%. We were intrigued by these results, but in order to write a paper about it, we needed kind of experimental evidence. So we decided to run an experiment. We randomized the sample in 3 groups. 1/3 got the original HRS question, 1/3 got the simplification that I just showed you, and another third got a further simplification where we separate the question about checking and savings from money market accounts. And the results are striking. For those who got the original HRS question, bank account ownership was 74%. For those who got the simplified version number 1, 85%. And among those who got the simplified further question is 92%, which is really at the population benchmark. And interestingly, when we run heterogeneity analysis by cognitive ability, we saw in this graph, you see on the x-axis, the quartiles of the cognitive ability score, and these are the treatment effects. So the treatment effect is systematically higher among those with low cognitive ability, indicating that simplification helps in a different way, different people, and especially those with poorer cognitive skills. This is the other kind of experiment, is on the side of the most difficult experiments to implement. This is a task experiment, and is really an experiment that actually 2 types of experiments that have been done in laboratory for the past probably 5-10 years, but have never been implemented in a population representative sample like the UAS. So the first part of the task aims to understand the so-called positivity effect that has been found in the lab. The positivity effect is that older people tend to remember positive events more than their younger counterparts. Is that true? And the way people have done this experiment, they show people a sequence of pictures. And these pictures can be neutral, positive, or negative. We used a sequence of 30 pictures, which is pretty standard. Each picture stays on the screen for 3 seconds. The respondent needs to look at the picture, and after that provides an emotional rating that can go from extremely negative to extremely positive emotion. And after the sequence, respondents are asked to recall as many pictures as possible and provide a very brief description. So for instance, if you recall these pictures, you may say 3 puppies, and it's one of your recalls. Well, as I told you, the results in the lab show that older people tend to remember positive pictures are a higher fraction compared to younger individuals. That's not what we find in the UAS. This is the composition of the recall. The big difference between people over 65 and under 65 is basically in how large the reddish area is, which means older people recall overall fewer pictures, but the composition between neutral, positive, and negative is pretty much the same between these 2 groups. The second part of this task was a learning task. In this case, people go through a learning phase where they see pairs of symbols. Each symbol can win some points or can lose some points. The interesting thing is that the same symbol can be a winner against one symbol and a loser against another symbol. So the task here is a learning task. You go through a long series of learning pairs. I believe it's 150 pairs, where you have to try to pick the losers and the winners. And then there is the game phase, where you have to play and try to remember as much as possible from the learning phase. The objective here is to understand if people learn more from punishment, so they try to remember more the losers, or from rewards, they try to remember more the winners. The interesting thing here is also that this task is pretty long. As I told you, it has 150 trials in the learning phase and 150 trials in the game phase. So these 300 observations for each individual are then used to fit an individual specific model. So we have then individual specific parameters that describe people's behavior. We have just estimated the model. I'm just going to give you one result, which is the F parameter. The F parameter measures how much people remember in the game phase what they have learned in the learning phase. And the lower this parameter, the fewer things you remember from the learning phase. And you see that older people have lower values of this parameter, which means they remember less from the learning phase. So again, this is very preliminary and we are working on this, but it's just to give you an understanding, appreciation of what can be done and how flexible the platform is. So if you have an experiment in mind, we can most surely accommodate it. Thank you.